function in terms of x instead of theta, it's easier for me to write x's. Here's a graph of the function on the interval from 0 to 2 pi. It looks like we have a relative maximum here at pi over 6 and a relative minimum here at 5 pi over 6. We might have a horizontal tangent line right here, but it's not a relative maximum because the function remains increasing. The question is, how do you figure all that out using derivatives? Well, I factored out the cosine of x to maybe make it a little easier to find the derivative using the product rule. So f prime is the first function times the derivative of the second, which means we'll have the derivative of sine as cosine, plus the second function times the derivative of the first, the derivative of cosine, negative sine. Distribute this negative sign here, and we get this, cosine squared minus sine squared minus sine. I know I want to set that equal to 0 and find out the critical numbers. So I think we better write everything in terms of sine. So I replaced cosine squared with 1 minus sine squared, combined similar terms, and got this right here. So there's a formula for the first derivative. We want to know when that equals 0. I don't like to work with a leading coefficient that's negative, so I multiplied both sides by -1, and then realized that this factors into 2 sine x minus 1 times sine quantity sine x plus 1. That means the sine of x equals 1/2, so x is the angle that has a sine of 1/2, or the inverse sine of 1/2. And that happens on the interval from 0 to 2 pi in the first and second quadrants, pi over 6, 5 pi over 6. Or the sine of x equals -1. What is the angle in that first revolution around the unit circle that has a sine of -1? 3 pi over 2. So these are our critical numbers. And we're just going to put those critical numbers on a number line. There they are, pi over 6, 5 pi over 6, 3 pi over 2. And test the sign of the first derivative in intervals that are created. And when the first derivative is positive, the original function is increasing. So you can see if I pick a test number in the interval from 0 to pi over 6, I can include the 0. That's easy to put 0 in for sine right here. And you get +1. So the function is increasing on the interval from 0 to pi over 6. There it is, increasing. Then from pi over 6 to 5 pi over 6, what number could we use? Well, we could use pi over 2 and put it into the first derivative. Sine of pi over 2 is 1, so we get -2 minus 1 is -3, negative. So the function is decreasing on the interval from pi over 6 to 5 pi over 6. There it is, decreasing. And then from 5 pi over 6 to 3 pi over 2, pick a number in this interval. Pi is a good one. I put pi in here. Sine of pi is 0. We get positive again. Back to increasing. And now what happens between 3 pi over 2 and 2 pi? You could pick a number like 330 degrees if you want to think of it in degrees, or -30. The point is you get another positive number. So we don't have a relative maximum or minimum at 3 pi over 2. That function just keeps right on going, increasing. So we have relative minimums, relative maximums here, and a relative minimum here. And the intervals of increasing, decreasing are as we specified earlier. There you go. Hope that helped. Post a comment if you have any questions.